Welcome everyone to Open Eco Homes and our allotment community and a low carbon legacy tour. My name is Alana. I'm the manager at Cambridge Carbon Footprint, and I will be chairing tonight's session. So without further ado, I would love to now introduce Dave, who will tell us all about his fantastic project. Dave?
Thanks, Alana. So I've got a pair of adjoining houses, and we essentially did the same work on both. This talk focuses on the house on the right in this picture. That's because it's got more features and it's now my home. I'd like you to notice the grey door in the centre of the photograph. That's a ground floor passageway, which is the only external access from front to rear. So just to give some context, we're looking at the block of 4 terraces, top right of the aerial image here. This photograph was taken towards the end of the building, so both of the extensions are in place and all the solar panels are in place. The builders hadn't quite left at this point. This is the house we are focusing on. And very importantly, this is my allotment. I started doing this plot in 1997, well before I bought the first house. And I can't overemphasize the importance of this. To me, it's not just a hobby, it's my community. And so some of the design had to take that into account. This is the other house I've got. And the red dashed lines here show my routes. I'm physically disabled and I generally don't go very far from home. So to a large extent, this is my world. I use these routes on foot, on my bike, on my mobility scooter, or pushing my wheelbarrow. And to get from the road to the garden and allotment, obviously I've got to go through that passageway. So preserving that route was a design constraint. Here we are right at the start of the build. The existing walls are brick with insulation in a 50mm cavity. The yellow rings in this photograph indicate known weaknesses in the existing shell, so we had to make sure we got those fixed up. The plan for the front was to insulate externally and add a porch to reduce heat loss at the front door. The concrete mouldings at the passageway entrance, put the laser pointer on to indicate those, they incredibly touched the inner skin of the cavity wall, creating a thermal bridge which took heat away from the corners of both of the living rooms. So it's good that we were removing them. But even worse, this passageway loses heat as the wind blows through in the winter. So heat's lost from both the side walls and also from the passageway ceiling. Because we were adding external wall insulation, that's EWI, we needed to ensure that the cavity insulation was consistent throughout. The photograph on the left shows bonded bead insulation, and I was pleased to see that filled all the nooks and crannies, so it looked like it was installed well and was doing its job. Although when you start knocking holes in walls, you've got to be aware the stuff goes absolutely everywhere. The balls fall apart, and builders do not tidy up after themselves. So I am responsible for probably millions of these polystyrene balls in the environment. Sorry. The photograph on the right shows cavity wall insulation that's rather older. It's orange fluffy stuff. That's got a poorer performance, and it had settled beneath the windows, leaving a gap. And there had been no consideration for where it met new bonded bead insulation at a corner. So that fluffy stuff needed sucking out, and here's some of the machinery they used to do that, and it was then replaced with bonded bead so that I got the new modern stuff throughout. This is in the center of this photograph, the old gas meter and the gas pipe, and that would have interfered with the EWI, which was going to be added on later. So I got it completely removed along with the meter. And the gas disconnection cost me, get this, £1,600. And the second time I did it for the other house, it cost even more. The alternative would have been to cap off the supply and somehow cut the foam insulation to fit around the pipes, because the pipes on the supply side of the meter are still owned by the network operator. But I wanted to preserve as far as possible my nice warm envelope. And frankly, I also wanted to make it rather harder for a future owner to switch back to gas. got a bit militant about that. So I paid the money to get rid of the old gas supply. In this photograph, we're preparing to add the EWI. The new windows have already been installed. The insulation material waiting here on the scaffold is polyisocyanurate, that's PIR, and that's a closed cell foam insulation. Our specification was 80 millimeters to meet the desired U value, but it turned out actually cheaper to do 100 millimeter comprised of two 50 millimeter thicknesses, even accounting for the additional labor of adding the second layer. At the top left of the photograph, I hope you can see there's a color difference, and that's because the installers have painted some sort of glue or sealant onto the surfaces before adding the next layer. There are two photographs here. The one on the left shows the first layer of PIR going on. And in the photo on the right, I hope you can see around the edge of the passageway entrance, you can see two layers of PIR. And I had a good look at this. The straight edges of the insulation boards seem to meet together nicely. And the boards on the second layer overlapped the meeting points of the boards in the first layer. So it looked like the installers had done a good job with that. These plastic pins, I think, were to hold the two layers of PIR together. And here we are adding the render. That's a 14 millimeter thickness, and it's a sort of concrete, a sort of nice off-white color. And I've now got two types of construction. There's the old brick walls covered with EWI and then the render, and new timber framed extensions, the porch, and also the larger extension at the back. And so they're timber frame build, and that's got the same type of render as we added to the existing structure. In a raised tie roof, like mine, the ceiling joists meet the rafters rather than the external walls. And between the joists and the eaves, there's this sloping ceiling. Now, everyone knows you should insulate the walls and the loft, but it's easy to overlook that this sloping ceiling is uninsulated. And I bet most residents don't know it, even though it's obvious when you touch this ceiling on a cold winter's evening. So how to insulate it? Well, unless you're removing the roof, insulation has got to be added from beneath. And this is a very messy job, but it could be done as a DIY task when you're redecorating. It's messy because you've got to bring the plasterboard down. So it's not it's not just a weekend job, really. We packed PIR 75 millimeter thicknesses into the gaps between the rafters. And then an additional 60 millimeters of PIR was attached to the rafters. And that was a product that's actually the insulation foam bonded to plasterboard. Now, if you were re-roofing, the between the rafters bit could presumably be done from above. Another thing just to point out in this photograph is this wall here, in the bottom left of the photograph, is a party wall. So on the subject of party walls, this is a photograph of a almost identical block of 4 terrace houses, just like mine. And I'd like you to look at the pattern of frost melt on the roofs. These horizontal lines are where there are vent tiles. So air exits through there, warming the roof slightly. But the vertical lines here, and to a lesser extent in the middle, is where the party walls meet the roof. And I believe this is because these party walls have a cavity which allows convection to move heat up from the living spaces to the roof, thereby warming the roof again and leading to slightly quicker frost melt. So yeah, so that's another source of heating loss, which we can do something about. I've got a question if anyone wants to propose an answer. Why is the melt slower above the central party wall than above this one and this one? Answers in the chat, please. Anyway, this was an opportunity to insulate my party walls because we have the installers on site anyway. There was some research led by Jason Palmer of Cambridge Architectural Research here in Cambridge, which showed that on average, insulating party walls like this only saves about 0.8% of the total heat loss from a house like this on average. Whereas insulating the cavities of the external walls saved about 6.5%. So doing the party walls is only a small win, but it's going to last forever. So why not just do it whilst you've got the installers in? The extension at the rear is timber frame, as I mentioned earlier, but here you can see the foil-faced PIR getting packed between the wooden elements of the structure. And again, that was done quite nicely. Here we have the passageway between passageway again. It's a recurring theme in this project. It's got an uninsulated concrete roof, and that was a significant heat loss from both houses. I mean, I didn't measure it, but you could feel it. And the heat is lost by the floors of the bedrooms which span above it. So we tried to reduce heat loss from this passageway in two ways. Firstly, we added doors at either end, the idea being that they kept closed in winter and open in summer. And also we added PIR to the ceiling. I think it was specified at 160 mil. And that's held in place by the wooden battens, which you can see. And again, it's this foil-faced PIR product. We couldn't add external wall insulation to these walls because that would make the passageway too narrow. So we'll see how that works out. There's another question for you. How would you insulate these walls? My old loft hatch, shown on the left here, was drafty and poorly insulated, and it was too small. My lovely new loft hatch has got no less than 3 rubber seals, pretty much eliminating drafts. It's got a board of PIR bonded to the top of the hatch and a nice integrated wooden ladder. And it's larger than the old hatch, which I like, but we needed to make a larger opening anyway for the larger vessels being installed up there. I'll talk more about those later. In fact, the builders needed an even larger hole than that to get something very large through. So they made a big hole and then reformed it to fit the loft hatch. Obviously, one restriction is the span between the joists in your ceiling up there. This one was quite expensive. It's a top of the range model, over £600, but there are slightly cheaper, lower specification models available. Initially, I had wanted to retain a suspended timber floor in the living room, but that sort of got complicated with the addition of insulation and underfloor heating. That's UFH. So we completely removed the timber floor to be replaced with a solid floor, and then I had the same construction throughout the ground floor of the house. We found an unexpectedly deep void, which I think you can see in the photograph. I instinctively wanted to fill that space with more insulation, but of course you can't do that because it moves a little bit. So we had to buy in hardcore to make up the height. So the new floor is insulated with 150 millimeters of expanded polystyrene, EPS, and it comprises 7 layers in all, without listing them all. Top layer is a lovely new engineered wooden floor, and just below that is 50 millimeter of screed containing the UFH pipes. I took the opportunity to put in some ducts for future services. These are the yellow pipes in the photograph on the left, and they're already used to bring internet into the house. In the photograph on the right, the first few planks of the engineered wooden flooring is being installed. It's 15 millimeters thick laminate floor with a 3 millimeter wear layer at the top, I think. The white cupboard in the left of this photograph is a naturally cool larder. It's got insulated walls and doors. There are vents into the passageway, which is effectively an external wall. And of course, we were carefully not to run the underfloor heating pipes underneath it, because that would have been a real own goal, trying to keep my vegetables cool and heating them at the same time. The left image here is a schematic from the heating designer, which shows 6 zones of underfloor heating. Each is controlled by a room thermostat, and the zones are shown on this diagram in different colors. Probably the prettiest image produced by my project. There are some white uncolored areas in the image. This is where my chest freezer goes. This is the larder, and there's also a cupboard and some other cupboards that we didn't want to heat. The image on the right is the UFH controller and the manifold, and the room thermostats are wired to this controller. Warm water from the heat pump enters via the pipe on the right, and that flow is indicated by red arrows. And then it gets distributed downwards into the 6 zones. The pipes disappear under the floor. The water circulates and gives up some of its heat, and then the cooler water emerges and returns to the heat pump. That's indicated by the blue arrows. The temperature difference is, I think, designed to be about 5 degrees. In my house, it seems to be rather less than that, often only 2 or 3 degrees. I don't quite know why. Something to discuss with the installer at some point. The flow into each zone is controlled by the flow setters, which are these 6 red devices at the top. Having said all that, now that I've read more about underfloor heating and heat pumps, it's not obvious that zoning the rooms like this in a house of this shape is a good idea. And if you want to dig into that debate, see Heat Geek channel on YouTube. Originally, the house had a separate toilet and washroom. I mean, why on earth you would build a wall between your toilet and your wash basin, I do not know. But anyway, nowadays everyone knocks them through to create one larger room, a bathroom. And one problem with that is that you've then got 2 windows separated by a narrow brick column, and that column was solid. It's got no cavity. So again, it's a thermal bridge losing heat by conductivity from the inside to the outside. So I thought it would be a good idea to eliminate that column. And so we added a lintel to strengthen over the top of the larger span and fitted a larger single window. So now I get a little bit more light and a little bit more passive solar gain. This is a south-facing window, so that's a significant win, I think. And we've eliminated that thermal bridge. All of the external windows set into existing walls are triple glazed wooden frame, and they're clad with aluminium on the outside, made by Turba, quite high spec windows. I really wanted to see wood in my project, so that's why I wanted wooden frame windows, but I didn't want the hassle and expense of maintaining wooden windows on the outside. So the aluminium cladding looks like a great solution to me. But I was adding 114 mil of cladding to the walls, so I was concerned that the windows might be a bit too far recessed. So I specified that the windows should be mounted into the existing brickwork reveals as far as possible, as far forward as possible. And I think that's worked quite well. And incidentally, back to the previous slide, it's given me lovely deep windowsills, internal windowsills, a little bit more space. So you know, sometimes something comes along which you hadn't realised was going to be nice, but there it is. The cats love to sit on these windowsills. Don't forget internal windows. These are original fan lights bringing sunlight into the stairwell, so I kept those and I actually added a new fan light downstairs. The bifold door on the extension is a highlight of the project. It opens fully onto the patio. Slight word of warning if you ever were to buy one of these. It's triple glazed, so the 3 panels are very heavy. And the product arrives with a stern warning attached saying that you've got to open it and close it properly, for otherwise you may bend the frame, rendering the door unusable, and that would be a very expensive mistake. One other little detail about my doors, I've got 3 doors and they are keyed alike, which is great, one house, one key. And the locks have got locking knobs on the inside. That's a really useful feature. Every day I benefit from that detail. You know, you're tired, it's at night, you want to lock up, but you can't find your keys. I just twist the knob to lock up. The heat pump is a 6 kilowatt EPODAN. The manufacturer is Mitsubishi. This provides heating via the UFH and also 2 radiators upstairs. The heat pump works okay, but the controller is not very intuitive and the app is truly awful. I've got 170 apps on my phone. This is the worst. So a word of warning there, you know, you're not just buying the heat pump, you're buying a service package and the software and controlling hardware that goes with it. My installers first of all wanted to fit an 11 kilowatt EPODAN, I then got them down to 8.5 kilowatt and then finally down to this 6 kilowatt model. I'm really not convinced by the heat loss calculations. They use a formulaic tool which refuses to account for passive solar gain, and which I've got lots of, or the mechanical ventilation system. They're just not included in the statutory heat loss calculator. I did check in advance that this type of heat pump can modulate its output down, but only much later I discovered that Ecodans only modulate down to about 31% of their maximum output. Now, my house is very well insulated, and often it only needs, well, maybe 1 kilowatt. And I cannot achieve that constant rate from this heat pump, unfortunately. So inevitably, there's some cycling. It switches on and off several times an hour, maybe 5 or 6. The installer thinks that's acceptable. I'm a bit disappointed because I think with a lower output, we at times when I only need 1 kilowatt, we'd have a better overall efficiency. There is some scope with experimenting with the settings, although actually, I mean, I'm a technical sort of person, but the number of settings and parameters associated with the heat pump really is substantial. I can't really get my head around it, to be honest. So we will see whether I manage to improve performance at all. The coefficient of performance, that's the amount of heat you deliver compared to the amount of electricity energy that you use, was just under 3 the last time I looked. However, the numbers that the Mitsubishi controller generate are not necessarily accurate. Even the installers don't quite know how Mitsubishi do it. They don't use heat meters, and that's what you really need to get an accurate measure of the heat pump's performance. You can buy a kit from Mitsubishi for hundreds of pounds and get that installed, or perhaps it can be done cheaper with some third-party heat meters. But I didn't know about that before choosing the heat pump. Seems wrong to me. I don't think you should be allowed to sell a heat pump system without an accurate way of monitoring how well it's doing. There you go. I've got a 210-litre vessel in the loft. The heat in there is provided mostly from the air source heat pump, although there's a little bit extra from surplus solar PV electricity, and that's controlled by a unit called iBoost. There's a lot going on in this system. There's a low loss header. These are expansion tanks. There's several pumps. There's a filter. It's all quite intimidating. I'm very pleased that Eco Installer, the people who put the heating system in, made me a nice 2-minute video tour of the system. So I know what all these bits are, and most importantly, I know how to isolate the water in an emergency. The floor at the bottom of this picture is a platform specially constructed as part of the works to take the weight of the hot water tank, plus a rainwater tank and a solar battery, which are not shown here, but all that adds up to quite significant weight. So we had to make sure we got something strong enough to take all that. And of course, that's insulated underneath. And I have a thermal image. You made, of course, with a thermal imaging camera borrowed from Cambridge Carbon Footprint. The image shows the warmer parts in orange and the even warmer parts in white. Now, this is a cold loft. I wanted the cylinder up here out of the way, but the disadvantage, or one disadvantage of that, is that any heat loss here really is completely lost from the heated envelope. So the image shows that the warmest parts are the pumps, one down here, and also the magnetic filter, which is center bottom right of the picture, and also where the pipes meet the vessels. Here they meet the low loss header, and here's some pipes meeting the main vessel. So those junctions and also the magnetic filter are places where I could do some DIY to insulate a little bit. It won't make a great deal of difference, but the work will be done forever. So why not do it? That's a project for me to do before the winter sets in. Now, this is the rainwater controller. The other main components of the rainwater harvesting system are a very large underground storage tank, which has got a submerged pump in it. And there's also a header tank in the loft. And the way it works is that water is pumped from the underground tank up to the header tank, which supplies toilets, a washing machine, and a tap in the utility room by gravity. And these indicator lights tell you whether you're currently using rainwater. One feature of the system is that it automatically does a weekly flush with mains water. And that's just to eliminate the possibility that anything nasty grows in the rainwater tank. There's a holiday function for the same reason. The header tank here we've taken the cover off the controls, so you can see there's bits and pieces, a little filter in the middle there, and some electronics and valves. The way it works is that the header tank gets refilled when its water level drops below some threshold, and that's designed to avoid continuous refilling. You don't want to pump 5 litres up there every time you flush the loo. What you want to do is pump 80 litres up there every 16th loo flush, if that makes sense, because it's more efficient. And separately to the indoors usage, the pump also supplies garden standpipes directly from the storage tank. And that storage tank, it is huge. Its capacity is 3,000 litres, but the external enclosing volume must be at least double that. So there's a very big hole. Lots of subsoil was dug up, and the soil it increases in volume by maybe 50% when it comes out of the ground, because there's obviously a lot of air gaps in there, and it was quite a job to get rid of all that. The parts for the rainwater harvesting system cost only a few £1,000s, but looking at the amount of work involved here, there's 6 guys manoeuvring it into place. There was a lot of work to dig the holes. The installation cost must have been much higher than the parts cost. Gutters at the rear of the house drain into the underground storage tank. The blue arrows indicate the route, going down through the gutters and then through these underground pipes. And the storage tank itself is already buried under hardcore in this photograph. A patio slab covers the access to the storage tank, and this part of the system was not designed very well, I'm afraid. The photo on the left shows the access panel removed, and at the top you can see the inlet filter, yellow with some transparent plastic on top. And the pump, you have to believe me, is towards the bottom of the photograph, underneath the water. It sits right at the bottom of the tank, but it's not visible here. In the photo on the right, the filter has been removed for cleaning, and the pump has been disconnected to replace it. And that's because the pump failed. I'm glad to say the supplier replaced it immediately under the warranty, so that was really good. But we don't know why it failed. It got a bit silted up, so we're a bit worried we might have an ongoing problem there. If sand and dirt is getting in there because of the poor insulation, then the pump might fail again. But time will tell, and we've got some ideas about how to improve the seal around the edge of the lid of the rainwater tank. I think my expression in the photograph on the left illustrates the joy that piped rainwater would bring to any gardener. It's very well known now that we need to reduce mains water usage, but this job of installing this rainwater harvesting system was very expensive, and there were no incentives or grants available for it. So I'm having a moan here. The only financial incentive for me was slightly lower bills. You could get more of a discount if you drain off outside of the sewerage all of your water, all of your rainwater, but I don't do that because I can't get the water from the front of the house into my storage tank. In the photograph on the left, I've highlighted the label indicating that this is rainwater. Taps got to be properly labelled to reduce the chance of someone drinking from them. I've also got several conventional above ground rainwater butts, and the photograph on the right, you can just about see a 650 litre tank, which takes the catchment off my greenhouse. Moving on to the ventilation system. These are 3 rooms on the ground floor, all served by 1 extraction unit. And the yellow rings show the extraction ducts in the ceilings. And in the central photograph here, the access cover has been removed, exposing the extraction unit with its motor and fan, and the yellow arrows show the direction of the airflow. This fan unit is the powerhouse of the ventilation system, This photo was taken while we were fixing the original incorrect installation. So we had to take the ceiling down, make an awful mess, and put it back in. And the reason for that was that parts of the ducting had not been sealed up properly. The system the system depends on having the right pressure, so that needed doing properly. The photo on the left shows the extraction unit with a filter being removed for cleaning. The fan is always on at constant pressure. The photo on the right shows the outlet duct, which responds to humidity. And the way it responds is by moving this flap where my finger is. So it's humidity controlled, and when the flap moves, it increases or decreases the area according to increase or decrease in humidity. Pressure is force divided by area. We're keeping a constant pressure. So when you increase the area, that increases the power used by the fan to extract air. And the air in my house is nice and fresh. It does feel nice. The other part of the ventilation system is these inlets, which also respond to humidity in the same way. And I should emphasize that the mechanism is purely mechanical. It doesn't require any power or batteries. I wasn't convinced that I needed all of the 4 inlets specified by the suppliers, which is a company called Air Eco. And that's because I didn't really want to make any holes in my nice new warm envelope. We compromised by installing these inlets in the 2 bedrooms, but not downstairs, because that part of my house is already quite leaky. So that's the end of the first part of my talk. Do we have any questions?
I'd like to start with sort of a broader question, really. What do you feel was your approach to the project? Because obviously you're quite unusual in that you've got 2 houses that you were trying to renovate at the same time. And what were the challenges, would you say, of doing that?
The project was very big. I'd say that was the main challenge, and I was going into this almost blind, really. You know, I'd done a little bit of DIY, but I'd never seen a project on anything like this scale. But because of my illness, I felt I was pressed for time. I mean, you know, it wasn't even obvious that I'd still be alive at the end of it, quite frankly. So I wanted to crack on with it. I thought that getting 2 houses done at once, or at least in the same contract, would get me some economies of scale. And I'm probably right about that. But it means that we weren't able to improve the design of the second house. So if I was to do it all over again, I would have done 1 house first, tried it out a little bit, and then done the second house, having learned from all my mistakes. I mean, especially given that the houses were effectively identical to start with, you know, there would have been a real advantage in doing that. So yeah, could have done it like that. I think that point probably generalizes to people who have not done a project like this before. I would start with something smaller, rather than the whole house renovation. I mean, what if I was supposing I was just doing 1 house, I could have done the porch first. So get to learn the process, get the designers in, get the planning permissions, get some builders. Maybe you'll end up using the same professionals to do a larger job later, but at least you'd know the process. So I think that's probably a more general takeaway.
That's really helpful, thank you. So Sheila posed a question around zoning, underfloor heating zoning. Is Sheila with us? Would Sheila like to ask that question? Okay, then I'll ask. So Sheila asks, can you explain why underfloor heating zoning was not ideal in your circumstances?
Yeah, so probably not. The people who can really can explain that perspective is Heat Geek, who have a channel on YouTube, and they are heating engineers who seem to know about heat pumps and underfloor heating. Their main objection is that zoning like this can cause extra cycling. That is, the heat pump turning on and off at higher temperatures, whereas really what you want is the heat pump running constantly at a lower temperature. The example they gave where zoning might be useful would be in an L-shaped house. because then you sort of naturally have two zones, because there's not a lot of horizontal air movement between the two halves of the two parts of the L. But my house is essentially a rectangle. So there you go. I did raise this with my installer, and eco installers are pretty good on this. They're interested, and the service engineer said that he thinks the jury is out on whether zoning is appropriate. This is a relatively new industry for our country. I don't think anyone really knows. And every house is different, by the way. That's the other thing about heat pumps. Yeah, so yeah. So I'm a bit out of my depth, really. Look at Heat Geek and then see if they've convinced you.
Heat Geek.
Again.
Very useful. So next we're moving on to Rainwater, and I think someone who's identifies as Stickleman Limited had a few questions. So can you identify yourself and unmute and ask Dave your question directly, please?
Okay. Can you hear us?
I can.
Yes.
Hi. What was the question?
Water. Do you need separate pipes or something?
Oh, yeah. So if you're going for rainwater harvesting, does that mean you have to have a dual system throughout your house? Some for rainwater using appliances and separate ones for normal water?
Yes. The only exception to that is that the rainwater system has this mains water flush facility. So the controller that I showed you has the functionality that it will divert the mains input, cold mains, up to the rainwater header tank, and it will empty the rainwater out of the header tank back into storage, fill the header tank with cold mains just to flush it through. And that's the only part of the system where the two types of water mix.
Okay, so it's a big replumbing job to use.
Well, yes, I mean, I was replumbing anyway.
Okay, yeah.
But no, I don't think it necessarily is a big replumbing job. You're keeping most of your mains water system. It's just a question of adding that controller to bring a mains pipe into the controller so that it can do this refresh function.
Okay, thanks.
And I think Kerry also had a question on a similar theme around the pipes. Kerry, can you unmute and ask?
Yeah, it was actually me had this question rather than Kerry. Wouldn't it have been possible to take a pipe through the top of the passageway to take the water from the front of the house to the back?
Well, I'd still have had to run it through the bedroom, wouldn't I? After it's coming in at the gutters at the front. I still somehow got to get it to the. Oh, so you're saying I would run a pipe underneath the ceiling of the passageway?
Yeah.
Dang! Why didn't we do that? That sounds possible to me. There'd have to be a drop on that pipe, wouldn't there? And we've got to make sure there's space for it. But yeah, that sounds possible, and potentially could retrofit that. I don't see why we couldn't. I know Caroline, the architect, is here. I don't know what you think.
I was just going to add, there's a significant length to the passageway. It's about 12. I've got the drawings open in front of me. It's something between 12 and 15 meters. So the fall on that pipe, and you've got two. You didn't mention, but you've got two side access doors into each property. So the pipe may, and they go up to nearly the ceiling, don't they? So I think you may end up getting a pipe in front of a doorway if you did.
We would
sort of that to get the fall on it.
We'd have to cut a notch at the top of each door, which starts to compromise the door's function of reducing the air flow.
And the alternative, I suppose, could have been to bring it down. You'd have again a significant fall on the pipe, but bringing it down below ground. But that would have involved sort of digging out right the way through the central passageway, and then making the tank, sitting the tank lower. The rainwater tank is a shallow dig tank, so it's trying to reduce the amount you're actually digging out in order to install it. So I think that would have been ended up being a bit lower in the ground.
Yeah, great idea though.
I think it's, yeah.
Unfortunately, I also added these porches at the front of the house, which do drain into the public sewer. So that would make me slightly below the required 100% threshold for getting that, and it's not a big discount anyway.
I mean, you've got water butts at the front, haven't you? Which does obviously not rainwater harvesting, but it does do
Yeah, but when
water
they're
collection.
full, when they're full, the surplus then goes into the public sewer, and that's the
Yes,
requirement.
yeah.
I think we can squeeze in just one more. So if Matthew would like to ask his question about heating, that would be great.
Yeah, just a comment really on the heating. One of how you control heat pumps in a very well insulated building is a classic and new problem. And in some ways, Heat Geek are right that you just say the whole building is heated. Don't worry about the zone valves. Just you want to balance it, obviously, so that you've got the right flow going into a big and a small coil. But beyond that, you just whack the whole thing on. And one of the things we did was if you just turn the heating off totally at night and measure how much the temperature drops in that sort of house with external wall insulation and all the rest of it, you'll probably find you get very minimal temperature drop. You may be able to drop by 1 or possibly 2 degrees. So actually, the easiest way of controlling it is just to pump some heat into the building in the morning until you've got enough that you want. So you might go to a 0.5 degree above your set point, then turn it off, and then do the same in the afternoon. So you have two continuous bursts of energy, which the heat pump will like because it's on for a longer time. And then you just turn it off in between. And obviously with your climate, I've forgotten what they call it when you have the climate balancing. So basically the higher the temperature outside, the lower the flow temperature and all the other bits and pieces that you have with it.
The compensation curve.
Yeah, temperature compensation curve. So you do your temperature compensation curve and then just have a very long, a long continuous run. And because your house is so well insulated, you're not going to notice that 0.5 degree drop in temperature anyway.
Yeah. Mitsubishi have this sort of compensation curve plus setting, which starts off with the compensation curve, but also makes some modifications based on what it's learned about the performance of the house.
Yeah.
How well that works, whether it works at all, I don't know. I'm pleased to say that I, to some extent, already do what you suggested. And that's because I'm on a smart tariff. It's the Octopus Cozy tariff, which gives me
3 times a day. That's
it gives me 2 cheap periods during the day. So during those periods, I target higher temperatures. The idea being that the heat pump is going to run then, and I turn the heat pump off during the expensive period on the tariff, and then it might run at the mid rate of the tariff, but it generally doesn't. So I think to some extent I'm doing what you already suggested, but perhaps not thinking about it in quite the same way as you were.
That's really interesting. I think we're going to hand over back to Dave for the second part of his talk. So over to you, Dave.
Okay, thanks. So I hired AC architects to do the design and the planning and then also the project management. We got the planning permission for the original design, and then I changed my mind, wanting external wall insulation instead. I was going to do a sort of patchwork of internal, but that change meant that we needed a second planning application. There was some work to do even before the builders arrived, the gas disconnection, getting a smart meter in, getting the party wall agreements in place, of course, and also the 100-amp electricity supply upgrade. And I can say more about that if anyone doesn't know what that means, but that's quite important. A tender went out to, Caroline will remember, I think it was 7 companies. I'm not going to give the actual costs here, but each of the 4 bids we received was a 6-figure sum, and the highest was 24% higher than the lowest. So quite a range there. And I ended up taking the second lowest bid. And the way it works is that there's a contract with a detailed schedule of what's to be done and the timescale. The image here shows the initial program of works. And I'm not wanting you to look at the details of it. It's just that there are lots of tasks and subtasks in there, and there are a lot of dependencies. And anyone who's ever managed a project will know that when one task slips, another one slips, and then everything depending on that can slip. And that indeed did happen, unfortunately, because the building company had problems, serious health problems, ironically, some of them rather similar to my serious health problem, problems with the recruitment, price rises, COVID, the supply chain. But I think they didn't manage it very well either, and that led to mistakes and delays. And mistakes because one or two of the tradesmen they sent were really not very good, like amateurs. Most of the guys arrived on site were actually pretty good, but it only takes one person who doesn't really know what they're doing and doesn't ask for help to make a mistake that then causes more delays. Also, I made some additions and alterations to the project after the contract started, and that certainly didn't help. For example, the mechanical extraction ventilation system was a post-start of contract amendment. And then the project slipped. The initial program was 10 months long. In reality, 27 months elapsed, and that included at least 12 months of unauthorized overrun. And frankly, I don't believe my contract would ever have been completed without a new site manager who eventually arrived in April 23. And he's well organized and good to work with. And I've no hesitation in including his contact details in the case study. So I've already talked about probably being a mistake, putting two houses in one contract. Do a smaller project first. This one was really quite ambitious, given that I'd not done it before. I mentioned one other thing I found out thinking about this. There are new standards for retrofit coming along all the time. There's PAS 2035, and there's a new contract published by JCT, replacing the 2016 version that I used for minor building works. And it follows their thinking about how the contract should better reflect retrofit works. I tried to salvage and reuse wherever possible. I managed to save some kitchen cabinets, which are now repurposed in the utility room, shown by the photo on the left. And also we salvaged an old patio to create the floor of the extended passageway, and that worked fine. However, we also salvaged an entire kitchen in the other house, and that worked out quite badly, I'm afraid. We also tried to reuse some PIR insulation, which had been previously installed under a timber floor. That failed because it had been glued to the floor joists, and so it wasn't possible to get it off with straight edges. In general, salvage and reuse proved quite problematic for these builders, at least. I mean, I do get the impression that salvage and reuse is not intrinsic to their worldview. The builders want a clear space to work in, and when they're putting in new kit, they want it to arrive the morning they're going to install it, because otherwise it is in their way. What they should have done with my old kitchen was store it off-site, but they didn't think about that. Here's an EV charger and a small slimline water butt on the porch. About the EV charger, probably would have been better to get that done independently by a specialist. And also check whether there was funding. I could have got funding for my EV charger because of a benefit I get related to my illness, but I didn't know that at the time I paid for it. There you go. The regular electrician who worked as a subcontractor on these works took many elapsed weeks to get my EV charger working, and I don't think he did the installation in the best way either. I'll say something about the fuse. If you're installing anything power hungry, like an EV charger or a heat pump or electric ovens, or several of those, you're going to need a 100 amp electricity supply. And modern houses will have that, but older homes might not. And the distribution network operator, which is UK Power Networks in Cambridge, is responsible for your upgrade. And the upgrade is free. Wow. But there is no guaranteed timescale, and they are short of engineers to do the work. And my upgrade turned out to be quite complicated because both of my houses were on a loop supply shared with the neighbours. So they needed de-looping, and then the upgrade to the fuse needed to be done. So there was 2 months lead time on that. And the engineers, I'm grateful, worked over a weekend to get all 4 houses done in one go. So there's another piece of advice. Check you've got a 100 amp main fuse. You probably have, but if you haven't, get it done. So check today, be ready. We're all going to have to go electric, aren't we? So it's inevitable. Yeah, and the rainwater butt there is a nice little idea. It doesn't take up much space and saves just enough water to wash the car. I took the opportunity to get some slabs laid for my new greenhouse and shed, and I included conduits for the electric power and a rainwater standpipe in the greenhouse. So that's rainwater piped from the underground storage tank. I didn't have that idea until I started drawing a sketch of the garden in order to design the space which the builders would be able to use as their yard. So I've got some more advice. Consider your whole site, everything on your property. I focus very much on the details of the design of the house. And some of these things in the garden are really a last minute addition. So I think you should get everything done while you've got the builders in. They've got the kit and they've got the skills, but they make an awful mess. So you really don't want them coming back. So after the builders had finally gone, we cleaned up and turned the builder's yard back into a garden, looking very nice this summer. And the garden brings us back to the allotment. And that's the reason I live here. And that's the reason I didn't want to move despite my illness. So that's a very brief version of the story of how this worked out.
That's really great. Thank you, Dave. Can I ask? Can I invite Matthew to ask his question? We might be able to squeeze just 1 or 2 before we have to wrap up. So Matthew first.
If you hadn't done the second one immediately at the same time, what would you have done differently?
Oh, lots. Okay. So a couple of big things. I've got a chimney stack and a wood burning stove in the living room. And you know what? I thought about getting rid of it, but I wanted to retain my little wood burning stove because at design time, which was like 2018, I didn't really trust heat pumps. You know, I wanted to have some backup heating just in case this newfangled idea didn't work. So I thought, let's keep the stove just in case. But now that the heat pump works, I can be sat in one corner of my living room with my friend sat in the other corner of the living room, and we can't see each other, which is a real shame. If we'd have removed the chimney breast, then I would have had a larger living room, and also I'd have had a flat wall, which is also the passageway wall. So I could have done internal insulation there, solving my problem about heat loss through the sidewalls into the passageway. And I didn't think about that detail at design time. So I'm a bit annoyed. It's too late to do that now, really. So that's one thing. Another thing I would have done differently, might have done differently, was to think about a 2-story extension. I chose to go 1 story because at the rear of the house we're talking about here. I chose to go 1 story because I didn't want to build a mansion, and I didn't want to be overlooking my neighbour's gardens, and it sort of felt a bit greedy. But with my disability, I find it really quite difficult climbing the stairs. I try not to climb the stairs more than once or twice a day. And having a lift put in would be really useful for me now as my condition progresses. So the easiest way to put a lift into this house would have been to build out 2 stories at the back and build the lift shaft into that space. It would be possible to squeeze a lift into the existing fabric, existing 2-story fabric. But I'm not quite, we'd lose space that was being used for something else. It's quite a small house fundamentally. So that's a couple of big things that I would have done differently. I'd like to think I'd have spent more time researching builders, because this company turned out not to be very good in practice, even though the architects had actually worked with them several times recently on successful projects. So they seemed to have a good track record. It's just that for some reason, well, various reasons that I did sort of allude to, things were going quite badly for them, and I got on the wrong end of that, unfortunately. Probably many other things that I would have done differently. Yeah, I'm not going to try and think of them all now.
Don't know if I can ask us that. Would you have thought about MVHR or?
Yes, and well, I already did, and I made. Oh, it reminded me of something else. You really got me going now, Matthew. So you asked about MVHR, and then I'm going to talk about ground source. So yeah, I sort of made an assumption that I didn't really have space to put the large diameter ducts that you need for MVHR through my existing fabric. You know, where floor joists run in one direction, okay, but then you've still got to take at some point, you're going to run a pipe at 90 degrees to that. So I suppose that would have had to have been achieved by adding visible ducting inside the rooms. But also the existing fabric is quite leaky, and I've got a hat flap, and I've got a letter box, and I've got an air inlet behind the stove. So I think I just rather lazily assumed that the house wasn't suitable for MVHR, and I ended up with this sort of partial solution of at least getting the ventilation part of it without the heat recovery. I should probably have taken some time to research MVHR more carefully, rather than just dismissing it out of hand. And then a second thing that I sort of dismissed out of hand was the idea of a ground source heat pump. Now, I understand that these are a bit more efficient and have lower maintenance costs than the air source pump. And although they're quite expensive to install, it wasn't as if I had money for this project, you know. So my concern was that I wouldn't be able to get the kit for drilling the very deep hole for a ground source heat pump around the back of the house into the garden. There isn't enough space to do it at the front because I'm only like 7 meters from the public right of way. We would have had space in the garden. I just assumed that we wouldn't be able to do it there. I have learned since that builders find a way, and it's actually quite funny. I told you they generated an awful lot of subsoil which needed removing from the house. Well, they had planned to barrow that out through the passageway. Unfortunately, they had a lot of problems with getting the drainage right, and there was a drainage cover, a drainage access hatch required in that passageway. And we ended up in a situation where exactly at the time they needed to shift all this subsoil, we were not able to use the passageway, certainly not the weight of a wheelbarrow full of soil. And the builders incredibly solved this problem by smashing a hole through the front wall of my house in order to get their wheelbarrows through to the roadside so the muckaway lorry could come and get rid of all the subsoil. I was really shocked when I saw that hole in my wall. Again, I reflected on it, and I had just been watching footage from the appalling war in Ukraine, so I thought, well, you know, first world problems really. But my point about saying that is that builders find a way. We could have got that drilling rig round the back of the house somehow. Then it would have got more complicated because then I would have had to run a heat main. So I'm assuming I could only afford like one ground source heat pump. So then you'd want to run a heat main to both houses, or even to 4 houses. I mean, why not supply the block? You know, make a deal with the neighbours. That would probably have got quite complicated. So there again. So yeah, I think as a general point of advice, try not to make any assumptions. Those of us who are thinking about these projects are in a slightly dangerous position because we're not experts, yet we know a little bit. So when you know a little bit, you can start making assumptions, and it might be better just to go with a very abstract list of your requirements to the professionals and see what solutions they actually come up with.
Thank you, Dave. That's really interesting. You know, you're bringing up community energy, which sounds brilliant.
So Nicole, were there more questions in the chat?
Yes. So I think we did have questions about rainwater harvesting costing.
How expensive is it to pay for the bits and then to pay for the people to install the bits?
So the bits themselves cost just a few £1,000s, and if you go to rainwaterharvesting.co.uk, which is our supplier, they've got prices on there. You can get them to send you a quote. I mean, you can quote this example from Open Eco Homes and say, I want a system like that, please, and just get an idea of the cost of the parts. However, the cost of the installation, I can't say, because for start, this was part of a much larger job. And the separate components of it were not priced individually. And I mean, I'm hoping I got some economies of scale, because they had the diggers on site for the foundations and digging the soak away. So there was already digging plenty of holes anyway. So I don't know how much the build is allowed for the installation.
Sorry, it's Sheila here. I'm with Stickleman. How much was extra was the header tanks? Because we talked to people as well about rainwater harvesting, and we didn't want a header tank, and they said, well, that's fine. You could have a tank in the garden, and you can have a top up from the mains, and then you can then pump out to a downstairs loo or 2 or 3, and the washing machine and the water pump. So I wonder how much of it, the installation internally, taking it up to the water tank in the attic, would have added to the cost.
Well, I suppose you could just look at the cost of the header tank from the suppliers. So
Yeah.
Quite.
Yeah.
You see, I don't imagine that's. It sounds technically possible. The disadvantage there, though, is in the efficiency of the system, because then you're sort of pumping on demand every time you flush the loo, which is exactly what my header tank system is designed to avoid.
Okay. Okay, thank you. Yeah.
Matthew's got a question.
Matthew, go ahead.
Just kind, really. If anyone has a caravan, then that's what they have. So basically, you can have a system where the pump does come on every time you use the tap or the toilet. You normally have a little, not a header tank, you have a pressure vessel, normally like a 20-litre pressure vessel. So it pumps up the pressure vessel, and then when you use the cistern and whatever else, the pressure vessel supplies from there, then pump starts. So it's not the end of the world. If anyone's got a caravan, you've got that system anyway. And you can install it. It doesn't cost that much. It's a little bit annoying because you've got a pump which you might be able to hear. That's the only downside. But otherwise, it's a pretty standard thing for any plumber to whack in.
It's funny you should mention that, Matthew, because I've got a problem with the rainwater harvesting in one of my houses at the moment, which is that the pump seems to come on every 2¼ minutes for a very short period of time and then go off again. And a mate of mine was round here and saying he'd had exactly the same thing in his camper van. We've been on the phone to the engineers at the rainwater harvesting company, and they're very helpful. They don't do site visits, but they seem to be very good on the phone. And he suggested it's likely to be a problem with the non-return valve on the pump. So that's a project for whenever it stops raining. We'll go out and have a look at the pump. Having replaced this pump once, I now feel quite confident about getting in there and doing that again. So
I can't wait to actually visit when you might have a bit of time, Dave, because it sounds absolutely amazing. The connectedness from the house to the garden and the allotment. To me, it sounds like a really sort of really well thought out scheme. So even though you have a few reservations about some of the things that have been done, it sounds absolutely amazing. So thank you very much for hosting us tonight.
You're most welcome, Nicole.